Hello, I am Auxiliaries Inspector, Lieutenant Commander John Letourneau, and I'm going to go over how the basic way we inspect the fire pump. And overall, the way we like to do the fire pumps is we like to test the any kind of remote operation that we have for the suction and discharge valves. In this case, we're on a DDG, so we're looking at remote operation, hydraulic operation of the suction valve, and we got manual operation of the discharge valve. So we're going to test. We like to test the remote operation of the suction valve first from the MEVAC station. And all we do is we have an operator up at the MEVAC station, and he or she will shut the valve. And at that point, what we like to do is we test the interlock. We've got a suction valve interlock, as you know, and the best way to test the interlock is to shut the valve and attempt to start the pump from all locations. Like I said, this is a DDG, so in this case, there's 3 locations. We can start the pump locally at the motor controller, from the DC deck at the MEVAC station, and then from CCS. So we're going to actually try and start the pump from each location, and obviously with the suction valve shut, test the interlock, it shouldn't work. Okay, so that's the first thing we check. Once we go through and check all that, then we're going to open up the suction valve from the MEVAC station, and the suction valve, you come around here, is in this case is right here, and obviously we're going to check. Here's your hydraulic lines. We're going to check those, make sure they're not leaking, and we're going to check, make sure that your isolation valves are open, your bypass valve is shut, just like the EOS says. We're going to check. We've got our indicator on here, so we're going to check that, and we're also going to check the valve itself. We're going to make sure that the valve is. We'll do the material inspection on the valve, make sure it's working properly, and make sure it's maintained properly. And that includes our indicator wires too. We're going to check those, make sure we don't have any electrical safety issues or wiring issues. And we'll check the operation of the pump, and the way we do that is we'll open up the suction valve, like I said, and then we'll start the pump. And we're going to start the pump from each location. Typically we'll start at the local motor controller, and that's over here. And on the motor controller, we obviously are going to check our lights, make sure we got our pump running light, our power available light, make sure everything works. We're going to check these little rubber boots here, and these are important because on a lot of ships we find these rubber boots are ripped, and unfortunately, if these rubber boots are ripped, that's an RBO. So that's very important that we check these before we even start, because we don't want to lose a sailor in this motor controller, because your finger can go right in there if that rubber boot's ripped. So make sure you guys fix those, because that's a real easy fix that can RBO a pump. Obviously, we check the material condition of the controller itself, make sure there's no wires hanging out, make sure there's no electrical safety hits, and make sure that everything's intact. Once we're ready to start the pump, the operator will start the pump, and at that point we're going to check our suction and discharge pressures. We're going to check the correct rotation of the pump. We're going to check for vibration. We're going to check for noise. We're going to check all kinds of things on this pump, all kinds of the material condition of the pump itself, and the pump and the motor itself. We're going to check inside this pump. You've got a little slinger ring in there. We're even going to check that slinger ring, make sure that that's in there, make sure that that any water that's running down this pump shaft's not going to end up in this motor. So we're going to look for that, and we find a lot of issues with that too, the placement of those, and sometimes they're missing. We're going to check the resilient mount. We're going to check the pump foundation. Make sure that the pump is secure on its foundation. Make sure that the resilient mounts work properly. The way I usually do it is I just give the pump a good shake. That's the best way to check, to make sure that you don't have any metal-to-metal contact anywhere in this system, and make sure that your resilient mounts work properly. We're also going to check, there's a little safety guard back here on the fan, the cooling fan for the motor. You can't see it, but it's back here, and make sure that you can't get human hands into this fan, because that would be a safety and that would be an RBO. So that's something that we see from time to time. Make sure that safety cage is intact, and make sure you can't get any sailors' hands in there. The pump motor terminal junction box, that your connection's good. You can't get any water intrusion in here. Everything's tight. The wire's tight, and this cover's on here well. Sometimes we find these loose, and sometimes we find the overload box loose too. So make sure that those are all tight. So like I said, we'll start this pump, and we'll check all these things. We'll do a quick check of each thing that I talked about, including our flex hoses. We'll check these obviously for make sure that they got the tags on them. make sure that they've got the all the hardware, got the proper hardware. One dummy check that I like to do is I have a magnet, and I check to make sure that if I'm looking at a system that's supposed to be a non-ferrous system, I make sure that my fasteners are also non-ferrous, and I do that just with a simple magnet. And I just go around and I just check these things. It's a very simple check, but it's something that can lose you some points in the system. And obviously that's a big deal because of galvanic corrosion. We don't want to have dissimilar metals in contact with one another, and then we're going to have corrosion. So we look at that stuff. So of course, once the pump operates, then we're going to check like I said, the suction discharge pressure. I'm going to check the gauges, make sure that the gauges are calibrated. I'm going to make sure the gauges aren't leaking. I'm going to check I typically check the root valves, make sure that that they operate properly, and I'll check the hook valves, or the isolation valves, make sure that they're not leaking and that they operate properly. So all these little things that we check, but it's just basically checking the health of this pump and its components. I'm going to make sure that any kind of recirc lines that we have, any vent lines or recirc lines are intact and not leaking. I'm going to go around and I'm going to look for leaks. I'm going to check, obviously, my suction and discharge valve. I'm going to look for leaks on those. I'm going to look for leaks at any kind of flange that we have. I'm going to check my lagging, make sure I don't have any leaks underneath my lagging. And as the pump is operating, I'm also going to make sure that here's my discharge check valve. I'm going to make sure my check valve's not leaking. And I'm also going to check, there's an indicator. I'm going to make sure that indicator lifts when we start this pump, and then it reseats when we secure the pump. So that's another thing that I look for. And if that doesn't move, then it's either a check valve issue or it's an indicator issue. Either way, it's a deduction. So you want to make sure that that's operating properly. Once we start the pump, we're going to secure it from each location. So the next step after we start it locally is we're going to secure it locally, and then we're going to start it from the DC deck at the MEVAC station, and then we're going to secure it from there. And then when we're done with that, we'll start it from CCS and secure it from CCS. That way we check the start and stop at each location, make sure that's all operating properly. And as we're doing that, we're checking our valve indicators at all locations. We're checking our power available light, especially when we do the interlock check. We're checking our pump running light, and we're making sure that we're getting all the indicators that we're supposed to get at each location. So that's why we will split our watch team. You typically have 3 inspectors, 1 local at the pump, 1 at the DC deck at the MEVAC station, and 1 in CCS, so that we can check all these things as we go through. And then once we're done with in this case, the number 1 fire pump, we'll typically work our way aft or work our way forward, however you'd like to do it. But we typically go on to the next fire pump and do the exact same checks. And that way we can flow easily and smoothly. One of the issues that we have is communications. So typically the ships that practice the fire pump and they get the communications down, they do well because they've practiced it, they know what they're looking for, the comms are good, and everybody knows what the other guy's doing, so they can kind of help each other out. The ships that don't practice and that just try and wing it typically have a lot of issues with comms and with the flow of the checks. And it typically takes a lot longer, and we find a lot more issues just because we're down here longer and because the ship hasn't found the issues themselves because they haven't practiced it. That's usually the best way to find these issues. I guess the last thing I would check is I would usually check over here the ground strap. It's another thing that we find problems with from time to time. The ground strap here is oftentimes loose, and sometimes the strap itself will be degraded to the point where it's no longer effective. So we'll check the ground straps and of course just the general material condition of the piping, the valves, the gauges, and everything else associated with the fire pump. So this concludes my basic check of the fire pump. I hope this helps, and we'll move on to the next issue. Thank you.